Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just love what we get to do each and every week, which is help you feel more competent and confident in your math skills going into this test that you're getting ready to take, helping you feel more competent and confident. If you have the math skills, but you don't have the confidence, that does not make for a good combination walking into test day. And if you have all the confidence in the world, but you just don't have the skills, that doesn't make for a good combination either. And so we are here to help build up both of those. Every Wednesday we are here. We work through math problems K through 12 or pre-K through 12. And so if you ever have anything that you're working through or you need help with, please don't hesitate to reach out and ask what you want to see in the upcoming weeks. I always have a next week section, and so I always like to include what those things are that you're specifically working on. So don't hesitate to comment in the comment box and let me know if there's something specific you want to see me go over in the upcoming weeks. I'm going to cover a variety of topics, but I can't possibly cover everything, and so just let me know. A little bit about me. I'm Amy Sink, and I am from the Central Florida area. Y'all, I don't know where you're from, but these winter storms have been wild. Like Florida, we got a cold front, and it was so cold today. I mean, I loved it. I love the cold. So I had this like long sleeve on at work with a sweater and a skirt. And then I just threw a jacket on, and people were like, why are you wearing a skirt? I was like, leave me alone. But I know it was like blizzarding, snowstorming all up in the Northeast. Did that affect you? Let me know in the comment box where you're from, what test are you prepping for, and did the massive snowstorm that came across the United States, did that affect you at all? I know some areas like Tennessee lost a ton of power. And then down here in Florida, we are going to have one of the longest cold fronts I've ever remembered. Normally we get a cold front and it lasts for a couple of days, but this thing is going to last into like the middle of next week. So I'm excited because I like the cold, but I wouldn't mind seeing snow, but not snowstorm blizzard level snow. So let me know in the comment box where you're from, what test are you prepping for, and did the snowstorm affect you and your family? If you have any questions, don't hesitate to ask while we are working through these problems. And let's go ahead and jump right into the first problem. The water level in a pool is 12 feet. Due to a leak, it is receding at a rate of 6 inches per day. The equation below represents the water level, y, after X days. After how many days will the pool be completely empty? After how many days will the pool be completely empty? 6 days, 12 days, 18 days, or 24 days? So there's a couple of different ways we can solve this problem. An interesting thing to note is that they've given us this equation here, but we don't actually have to use it. If you're somebody who is more hands-on math and not so much algebraic, if you more like think about math rather than algebraically do math, then let me show you something. When we solve this problem, I always like to start with a picture. So here's my pool, and it is 12 feet high in water, right? Due to a leak, it's receding. Now, let's say you didn't know what receding meant. And you're like, Amy, this is a math test, not a vocabulary test. Well, if there's a leak, the water is going down. So my water level is going down at a rate of 6 inches per day, not 6 feet. Number one mistake people are going to make. They're going to go, oh, it's going to go down 6, and then it's going to be down to 0, and that's only 2 days. Well, that would be 6 feet per day, which would be an obnoxious amount of water to lose every day. That's a big leak. No, we're talking about 6 inches per day. Well, then I know in 1 foot, there's 12 inches. So if it's 6 inches per day, then it's going to take 2 days to go an entire foot. And then it's going to take 2 more days to go an entire foot. Well, if there's 12 feet, how many times is that going to happen before I'm completely empty? It's going to take 24 days, because for every 2 days is a foot. So 1 foot, 2 foot, 3 foot, 4 foot, 5 feet, 6 feet, 7 feet, 8 feet, 9 feet, 10 feet, 11 feet, 12 feet, right? So that's one way to do it. The other way to do it is to use the equation. But like I said, the equation confuses some of you, so I want to show you both ways. The equation below represents the water level. Why? So I know that this right here is my water level. This is the number of days. So the question says, after how many days? I'm looking for days. So I'm going to plug a number in for the water level, because this is what I'm trying to solve for. The question literally told me that. After how many days? That's what I'm solving for. So I'm going to leave X as X plus 2. Will the pool be completely empty? What's my water level if my pool is completely empty? 0. So 2 times 0 is 0. So X equals 24. Still the same answer, just 2 different ways to go about it. Let's move on to the next problem. what is the value of sine 5 pi over 3? What is the value of sine 5 pi over 3? So if you are elementary, GK, Praxis Core, you can tune me out for a minute. Don't leave because I've still got plenty for you. But this right here, this is a calculus problem. This is for my pre-calc and calculus people, my high school people. So let's chat about this. This is my unit circle. So 1, 1, 1, 1. Okay. There's a perfect circle, so we're going to pretend like I drew a perfect unit, right? Okay. There we go. So we've got my unit circle. When I'm doing cosine and sine of something like this, y'all, if you have the unit circle, at least operational in your brain, these problems are simple. If you don't, it's a guessing game and you move on. There's no reason for you to sit here and stare at this if you don't know the unit circle. I don't have this memorized. I would not be able to look at this and immediately know my answer. However, I do have enough knowledge of the unit circle that I can work through this pretty easily. So I know that this right here is an x value of 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is also 2 pi. Following? I also know that my pi over 4s are in the middle. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. I also know that the in-betweens are pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. So where does 5 pi over 3 land? Which pi over 6 is that? 5 pi over 3 is the same thing as, if I multiply the top and the bottom by 2, I don't change the value of this. So this becomes 10 pi over 6. So I'm looking for 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here is 10 pi over 6. Now, what does that even mean? They want sine. When I'm looking at this, I'm thinking about what is the coordinate point of all of these points in my greater coordinate grid. If you think about a regular coordinate grid like this, right? And let's call this our origin. The unit circle is literally, if this is my origin, right there. It's a circle with points at 0, 1, 1, 0, negative 1, 0, 0, negative 1. And all of these points on my circle have a value that has an XY, right? Anything on here has an XY value. It's just not clean. So I'm looking for my XY value. XY, the cosine is going to be your X, and the sine is going to be your Y. Now, when I look at this, I can very easily see that I am really, 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 really close to that one value. But if I look here, I'm right about at the halfway mark between 0 and 1. So my x value is 1/2, and my y value is going to be negative because I'm going down, square root of 3/2. You only have to know those two values, 1/2 or square root of 3/2. Every point on this that's not 0, 1, 1, 0, and that's not a pi over 4 is going to be either 1/2 or square root of 3/2. The pi over 4s are all going to be square root of 2/2, square root of 2/2, and it's just going to depend which one is negative and which one is positive based on what quadrant you're in. So for this, I'm looking for my sine value. So I'm looking at my y value of this, which is negative square root of 3/2. Now, I very easily could have gotten rid of d because I knew this wasn't a pi over 4 fraction. So at least I'm down to A, B, and C if I didn't know anything else. All right, that was a fun calculus, pre-calculus problem. Let's see what's next. Simplify. 3 minus 9, parentheses, negative 2 plus 3, divided by, parentheses, 3 minus 5. All right, this right here is order of operations. That's what we're going to use. So we're going to use PEMDAS. Please excuse my dear Aunt Sally. Now, parentheses, exponents come first. Multiplication and division come next. Addition and subtraction come next. However, you notice that I bracketed these together. Multiplication and division, and then addition and subtraction come together, as in we move from left to right. So if I come across division first and then multiplication, I'm going to divide and then multiply. But what I'm not going to do is I'm not going to divide, then add, then multiply. I have to do all of my multiplication and division together. However, I'm going to move from left to right, whatever comes first. And the same is true for addition and subtraction. So when I look at this, I need to complete all of my parentheses first. So I need to do this, this, and this first. 3 minus 9 is negative 6 times negative 2 plus 3 is 1 divided by 3 minus 5 is negative 2. And you ask, how in the world did you get that? Great question. When we think about a number line, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. When we think about a number line, and I'm thinking about what I'm doing here. In this problem, I'm starting at positive 3. 1, 2, 3. And then I'm subtracting 9. Think about this. When we add, we usually go to the right. And when we subtract, we are going to the left. So if I'm subtracting 9 and I'm only at negative or at positive 3, I'm going to end up going over that 0 hump and kind of starting over, which is why I land at negative 6. 1, 2, 3, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's look at that again with another problem. Negative 2 plus 3. Negative 2 is right here, but I'm adding, so I'm going to the right. I'm adding 3. 1, 2, I'm going over that 0 hump, so I'm kind of starting over 3, and I land at positive 1. And the same process can be used for this one as well. So now I'm going to make this a little smaller. Now we've done our parentheses. There are no exponents. So now we're going to do multiplication and division in the order that we see them. So I'm going to multiply -6 times 1. I'm going to multiply -6 times 1, and I'm reconnecting my iPad right now. It's thinking. All right, so -6 times 1 is -6 divided by -2. And then -6 divided by -2, a negative divided by a negative equals a positive. So that's 3. So my answer is B. Questions? Let's go ahead and move on to the next problem. A square playground is built using 288 yards of fencing. About how many square feet does this fence contain? About how many square feet does this fence contain? So y'all, you know what I like to start with. I like to start with a picture. So I'm going to draw my square playground. Okay, there's my square playground. And it's built using 288 yards of fencing. So if I were to walk around this playground, I'm going to use 288 yards. So how in the world am I going to figure out the actual area of my playground? How in the world am I actually going to figure out the area, square feet of my playground? Well, first I have to figure out how long the width and the length are. Because area, as you know, equals length times width. So if I can figure out what my length and my width are, and if you put an L on the bottom and a W on the side, it really doesn't matter because multiplication is commutative. But we have to figure that out. Well, what do I specifically know about a square? A square has 4 equal sides. And so if I do 288 divided by 4, if I divide it out among 4 sides, that gives me the length of one side. So I'm going to use my handy dandy calculator. And I'm going to do 288 divided by 4. And that gives me 72. So I know this is 72, this is 72, this is 72, and this is 72, right? Now I can take that and I can do area equals 72 times 72. And I'm going to use my handy dandy calculator again. 72 times 72 equals 5,184 yards squared. So my answer is B. Now, if this was a rectangle, this would look a lot different because I would have 2 L's and 2 W's, and they would have to give me some more information about the relationship between my L and my W, like L is 2 more than 3 times the width or something. And it would require a little bit more algebraic solving to figure out, but it would still be possible. But in this case, with a square, we know all 4 sides are the same, so it makes our job a little bit easier. Let's move on to problem number 5. Which of the following describes the relationship between these two lines? Which of the following describes the relationship between these two lines? All right. So my answer choices are going to cue me in on what direction I'm going with this. Because when I look at that, if I just were to read this right here, I would think to myself, whoa, I don't even know what this is asking. But the minute I start reading my answer choices, I realize, oh, they want to know if the lines are parallel or perpendicular or coinciding or intersecting, but not parallel. So I'm going to quickly, before I start solving this, think parallel lines have the same slope. They never intersect. Perpendicular lines have negative reciprocal slopes. So A over B and negative B over A. And then intersecting but not parallel, they just intersect, but they're not perpendicular. Intersecting but not perpendicular. They intersect, but they don't have this specific relationship. And coinciding is the same exact line, one line on top of another. So this all tells me I need to find out the slopes of these two lines. What form are these in? These are in standard form. You're absolutely right. These are in standard form, which means there's not a whole lot we can do with them. So I have to move things around to figure out what the slope is. My favorite format is y equals mx plus b, because m is my slope. So if I can get y by itself, then I can find my slope. That's pretty easy to do. So let's go ahead and move some things around. I have negative 2x plus 3y equals 8. Move some things around to get y by itself. I'm going to add 2x to both sides. Whatever I do to one side, I have to do to the other. So I end with 3y equals, I'm going to keep the 2x in the front only because in my format, it's in the front, plus 8. Divide both sides by 3. Y equals 2/3 x plus 8/3. Now, you might be looking at this and thinking, that's a lot of fractions. It doesn't matter. All I needed was the slope to figure this out. Now, let's look at the next one. 4x minus 2y equals 7. I'm trying to get my y by itself. I want to isolate this. So I'm going to subtract 4x from both sides. I'm going to keep the negative 4x in the front. So I'm left with negative 2y equals negative 4x plus 7. Divide everything by negative 2. Y equals negative 4 divided by negative 2 is positive 2x minus 7 over 2 or plus negative 7 over 2. And this is my slope. So I have a slope of 2/3 and I have a slope of 2. What does that tell me? That tells me they're not parallel because they're not the same. They're not perpendicular because they're not negative reciprocals. The negative reciprocal of 2/3 would be negative 3 over 2. These are not reciprocals. And they're not the same. So they're just intersecting lines, but not perpendicular. Now, what is the difference between parallel and coinciding? Parallel would be like y equals 2/3 x plus 8/3 and y equals 2/3 x minus 4. Coinciding would literally be y equals 2/3 x plus 8/3, y equals 2/3 x plus 8/3. They may not look the same here, but when you start moving stuff around, they look the same at the end. All right, let's move on to the next problem. Which of the following shapes does not have two pairs of parallel sides? Which of the following shapes does not have two pairs of parallel sides? So this is an interesting question that I'm going to preface with, it depends on what state and what test you're taking. This should say, which of the following shapes does not have to have two pairs of parallel sides? Because if you are in the state of Florida, the definition of a trapezoid is at least one set of parallel lines. This is at least one set of parallel lines. In other states or on other tests, it might say exactly one set of parallel lines. Why is that important? Because in the state of Florida, this is a trapezoid because this line is parallel to this line. This is a trapezoid, and that's kind of what we all think of when we think of trapezoid, because this is parallel to this. But this is also a trapezoid because this is parallel to this, and it's at least one set. But in the states where the definition is different, so you would have to look at your test and figure out, what does my test define a trapezoid as? Exactly one set would mean these are trapezoids and this one is not, because you also have this is parallel to this. So exactly and at least make a big difference. So which of the following shapes does not have two pairs of parallel lines? It's the trapezoid, because these all have to have two sets of parallel lines, where the trapezoid does not. Does that make sense? English is such a funny language, right? Like exactly versus at least. Who knew that you needed to know all of that English to be able to be good at math? All right, let's move on to the next problem. Which of the following shapes has equal angles? Y'all, quadrilaterals are always so fun, but so complicated. Quadrilaterals are one of my favorite things, but they are so complicated. So, which of the following has equal angles? So, a parallelogram. If I draw a really dramatic parallelogram, is this acute angle the same as this obtuse angle? No. If I draw a really dramatic rhombus where all four sides are the same, is this the same as this? No. When I draw a rectangle, what do I know about all my angles? They're all 90 degrees, no matter what kind of rectangle I draw. It doesn't matter if it's really dramatic or not, they're all still going to be 90 degrees. So the rectangle is going to have equal angles. All right, we're going to move into a little bit of something different. So the next problem is going to be something where it's a commonly asked for problem. When I'm tutoring, in our boot camps, when we're live, people will ask for this work concept. And so I could have created 3 separate multiple choice problems out of this one problem. And that's the goal when we're working through this problem together tonight, is I want you to see that we could have created multiple different problems from one singular problem. So let's take a look at this. A can complete a piece of work in 12 days. B can complete a piece of work in 18 days. How much work does A complete in one day? Well, A is completing if the piece of work is my whole. I need everyone to pay attention to this one, because this is not just a middle school and high school problem, even though it seems like it is. Like the language sounds like it is, but it is absolutely not just a middle school and high school problem. So my piece of work is my whole in my fraction. A can complete a piece of work in 12 days. How much work do they complete in one day? Well, 1 is my part, and the whole thing is done in 12 days. So A completes 1/12 of the work in one day. So then how much work do A and B complete together? What do we think of when we think of together? We think of addition. So if I'm adding what A completes in one day and what B completes in one day, and I add them together, then that's how much they complete together in one day. So then I need to use this same question to figure out how much work B is completing in one day. B is completing in one day 1/18 of the same job. So now if I add 1/12 plus 1/18, I can get how much work they're completing in a whole day, correct? Get common denominators. What is my greatest or my least common multiple? 12, 24, 36, 48, 18, 36. There it is. So if I multiply this by 3 and I multiply this times 2, I get 2 36ths plus 3 36ths equals 5 36ths. So how much are they completing together in one day? 5 36ths. In how many days will it take them to complete the work together? Well, if this is one day, I need how many days it's going to take them to complete the job. How many days is it going to take them to get to a denominator of 36? 5, 10, 15, 20, 25, 30, 35. Have I completed the job yet? 40. I'm going to have to go into that next day to actually complete the job. So that's 1, 2, 3, 4, 5, 6, 7, 8 days to complete the job. Now, if this was a multiple choice problem and they said like 7 point something, then you could go with that. But if they're asking for whole complete days, then that would have to be your answer. How fun was doing that problem together? Let's do one more like that where we just kind of work through without the multiple choice barrier there. The sum of two numbers is 40. 3 times the smaller number is 6 more than twice the larger number. Form two equations using the given information. Solve the equations to find the two numbers. Find the product of the two numbers. All right, so form two equations. If that's the only thing we have to do, let's look at this. I'm going to define my variables. I'm going to say x is my smaller number and y is my larger number. So the sum, answer to an addition problem, of two numbers, x plus y, is 40. 3 times the smaller number, 3 times the smaller number is equals 6 more than something plus 6 twice the larger number, 2y. There's my two equations. Check. Solve the equations to find the two numbers. So now I can do one of two things. I can use substitution or elimination. In this situation where substitution is quite easy, I'm going to do substitution. So I'm going to subtract y from both sides, and I'm going to get x equals 40 minus y. Now, x is the same as 40 minus y. So I'm literally going to take this 40 minus y and plug it in for the x. 3 times 40 minus y equals 2y plus 6. Now I literally just solve for y. Distribute. 120 minus 3y equals 2y plus 6. Add 3y to both sides. 120 equals 5y plus 6. Subtract 6 from both sides. $114 equals 5y. Divide both sides by 5. Y equals 22.8. Now, just plug it in. X plus 22.8 equals 40. Subtract 22.8 from both sides. X equals 17.2. And then find the product of the two numbers. The product is just the answer to a multiplication problem. So if you had to do that, then you could just multiply the two numbers that you found. Now, typically when we solve these types of problems, they give us whole numbers. I wouldn't be afraid of it if you got decimals unless you were solving a multiple choice problem where the multiple choice didn't have decimals, and then I wouldn't finish. So that's a good test taking tip. If I had like A, find the two numbers, 15 and 30. B, 12 and 18. C, 32 and 18. And then D was the same. And this is what you got for Y. You're done. You need to redo. You need to restart. Quite frankly, if it says find two things and you find one, go back to your answer choices and see if one of those things is in your answer choices, because that's going to be at least an opportunity for you to see if you've done something wrong or for you to eliminate some of the answer choices. Test taking strategies are important, especially when we're taking tests like this. All right. If you have any questions at all that you want to see me go over in the upcoming weeks, please don't hesitate to let me know, and I'll be happy to add them to my next week's section. I'm going to turn it back over to Dr. A, and I will see you guys next week. Have a great week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.